Hello guys, welcome to this video. In this video, we will be learning about EDA or Exploratory Data Analysis in Python. So before we move on to the video, I will explain the format which we will follow throughout the video series. So throughout the series, we will create 2 to 3 data analytics projects using different data sets and applying the techniques which are included in EDA so that you get an hands-on coding experience with me while I teach the concepts. So the link to all the collaboratory notebooks will be available in the description section below. So you can go to this collab notebooks as and when I teach the concept on a specific data set and on a specific collab notebook. So you can do hands-on coding with me. So moving on to what is EDA. EDA or exploratory data analysis is an important step before you create any machine learning model or before you move on to analysis of data. So EDA includes steps like cleaning data, which includes handling missing data, finding relevant features inside of a data, and also to read and display a data in format in which an end user is able to understand. Before applying any machine learning techniques or before applying any analysis techniques, data pre-processing is required, and data pre-processing is the first step in any data pipeline or any data analytics project. So EDA is useful for that, and we will be learning EDA with the help of Python, and we will use a library called as Pandas and NumPy to perform the processing on our data. So moving on to the first data set and the first few concepts of EDA in a video series. And in this video series, there will be 2 to 3 videos, each on a different data set. And there will also be a combined video in the end in which all the 3 videos are merged so that you can view it in a single video. Thank you. Do like and share this video so that it can reach to a larger audience and I can create more such videos on different topics for you guys. So let's move on to the first notebook. So the link to this collab notebook will be available in the description section below. So we will be using something called as the Pandas library in Python. So Pandas is a library which is used for data manipulation and data analysis purposes for pre-processing and handling imbalances which are present in data. So you need to go to this link which is present in the description section below. Make sure that you save a copy for you in Drive. So whenever you do any changes, it gets reflected and it gets saved in your Google account. So first step which you have to do is save a copy of this in Drive so that you can work on your own copy rather than changing mine. So once your copy is made, you have to download the dataset link, which is also present in the description section below. After downloading the dataset, you need to click on this icon here in Google Collaboratory and let it connect to a runtime so that you are able to upload the file here. So once this gets loaded, you need to click on this option to drop the data inside of this collab. So the link to this dataset is mentioned in the description. So once you add the data here, we will start working and learning the concepts of EDA or exploratory data analysis with Python. So the first step included here is to import the libraries. So as I mentioned, we will import a library called as Pandas, and it comes pre-installed in the Google Collaboratory. So to import libraries as Pandas library, all you need to do is, if you are familiar with Python, you use the import statement and write the name of library, import Pandas. General convention to use Pandas in Python is using an annotation of PD. So we import Pandas as PD, and PD is an acronym for the whole Pandas library. So the next step will be to import the dataset. Now to import the dataset in Python or in Pandas, there is a function called as read underscore CSV. So as this our current dataset is a CSV file, we will use the read CSV function to read this file. So to read this file, you will create a variable which will be of a data frame format. If you go into Pandas library and see what a data frame stands for, you will understand what a data frame is. So I will name it as DF, short form for data frame, which will be equal to PD, which is our library, and I will use the read underscore CSV function. So if you see the autocomplete, you will see that different types of files like Excel, HTML, JSON, all can be read using the Pandas library. So currently we have to read a CSV file. So we will use the read CSV function and pass in the name of file. So we need to pass in the name of file. So if you don't want to type this name, you can directly click on here and copy path and paste that path here. So that will download the that will read the CSV file and store it in the DF variable. So if you want to see this file, you will directly use the DF after reading this file, and I'll need to run both of these cells. So after importing, if I run this cell, you can see that this is my data frame or this is my data set. If I open it side by side, you will see that it also creates an index column alongside this. So it can be accessed using Python. So after reading this file, if I want to, let's see, read top 5 rows of dataset. So under the pandas library, there is a function called as dot head, which is df dot head. It will enable me to see the top 5 rows in the dataset. So if I write df dot head, I can see the top 5 or the first 5 rows of dataset. And similarly, if I want to see the last 5 rows, I use something called as df.tail. So df.tail allows me to view the last 5 rows of dataset. If I want to see total number of rows and columns in dataset or see the shape of data set, to view this, you can use the df.shape method, df.shape. And if I run this, I will be able to see what is the shape of my dataset. 51,6. 51 is the number of rows in the dataset and 6 is the number of columns in the dataset. If you are unsure or if you don't know how to do this, you can directly see what you want and search on Google to see. If I write, I want to see the shape of my dataset using pandas. If I write this, I will get the function which needs to be used to get what I need. If I want to see all the column names present in my dataset, I can write df.columns, and if I run this, I will be able to see all the columns which are available in my dataset. So these are all the columns which are present. It gives me a list of columns. So this way we are able to read and process the dataset using the pandas library in a simpler format. So now we move on to a little more needed concept, which is checking for missing data. So if you would see the tail of dataset, you will see that there is NaN or the values of this row are missing in my dataset. Now this dataset is of shape 50. It means it only has 50 rows. But what if my dataset is a very big dataset which has over, thousands and lakhs of rows or columns? So for that, we can use the missing, we need to check for missing data. So before we proceed with the analysis, we need to figure if there are any missing or junk data in a data frame. To do this, there is an isNA function in pandas. You can find more about isNA in the pandas library. So I will show you how it works. And if I just want to see if there exists any NA method, if there exists any null values in my data set, I can directly call df.isNA on my dataset. And when I run it, it will give me an row-wise analysis of whether there is missing data in the cell or not. False implies that there is no missing data here, and true implies that there is missing data in these cells in my dataset. Now, again, if I have millions and lakhs of rows in my dataset, it is not feasible for me to check each and every row like this to see if there is missing data in my dataset. So to do and to check if missing values exist in my dataset, I can do df dot is na values dot any. If I write this, I will get true if there exists in dataset any values which are null. So this means that there exist null values in a dataset which can be seen here. And if you want to see or count the number of missing values, you need to write df.isNA.values.sum. Now this will give me the total number of NA values in the entire dataset. As you can see, there are 1, 2, 3, 4, and 5 missing values in our dataset only in the last row. And this can be used to check or count the number of missing values. And let's see, on processing or during processing, we want to delete the last row. To delete the null rows or NA rows in our dataset, there is a function called as drop NA in our pandas library. So this creates a new data frame and returns a new data frame. So if you see, if I write df.drop_na and I print df again, you will see that the NaN value is still present in my dataset even after using the drop NA. So why is this happening? Because this function returns a dataset, and this returns a dataset which needs to be captured. So you need to define a new dataset which is a which captures the dataset returned by the drop NA function. So I'm storing the drop NA's value in the clean data frame now. And if I print clean now, you will be able to see that my null value or a row containing null value gets deleted from the dataset. So in this format, it can be used to drop the rows. But if I want to do in-place changes in my existing data frame and not create a copy of the data frame, there is something called as the in-place function, in-place argument inside of this function. So let's see the drop NA function in pandas. So if we move on to the drop NA documentation in the pandas library, you will see something called as an in-place argument. So what this function returns is a data frame or none, data frame with NA entries drop, or none if in place equal to true. So if I write in place equal to true and print the data frame, you will be able to see that my changes happen in my DF only, and my existing data frame which I declared above, in that only my null values are dropped. So this way we delete the rows having null values in Python. Moving on to accessing data and individual cells in data frame. So if we want to access specific values, like we want to access a specific row or access a specific column, how we can do that in pandas is very simple. So first, let's print all the columns which we have in our dataset using df.columns. So df.columns can be used to print all the columns. And in the if you're sticking till now, do like and share the video and subscribe to my channel. In the end of this part, or in the end of processing this dataset, there is also a challenge section which we will cover, and the learning points and summary as well. So the challenge section is something which you guys have to do, and I will share the solution for it as well. So stay tuned for that as well. And if I want to access a specific column, so to access a specific column, you use it like you are slicing a list in Python. So all you can do is df and write the column you want to access. So if I want to access the column undergraduate major, I will write the undergraduate major, I will write the name of the column, and if I run this code, I will be able to access the values of all the values present in the column undergraduate major. If I want to find a max value of that column, if the column contains numerical values, and if I want to find the max value of that column, let's say starting median salary. So to do that, you will write df, the name of column, which is the starting median salary, and you will simply use the max function, max. Yeah. So this function will return the max value of this column. Now it is returning me the max value, but I want to know the row or the index of the row in which this value exists, so that I can do analysis on which column or which row has the maximum value. To do that, you use something called as the IDX max method, which returns the index of the max value. So if I copy this and write the IDX max, it will return me the index of where this value is located, which is at 43. To see which of the major correspond to that row, we can use something called as lock property. So if I write df this only, and if I write the dot lock 43, which is the index which is returned by this, and I run this code, I will get the same value, you see. And if I want to retrieve the entire row, I will just write df.log 43. It will retrieve me the entire row, which consists of this, of the index 43. So as you can see, the starting median salary here is 74,300, and the major it was under was physician assistant. And you can see all the other column for the value which has maximum of starting median salary. So in this way, we are able to access a specific row or a column or an index in the data frame using the dot log function. And we can also use dot min function to find the minimum value, or IDX min, and similar functions for that. More such functions or arithmetic functions are present in the pandas library, which we will also cover in future processing of future data sets in this video. So let's move on to the sorting values and adding columns. So let's see what is a low risk major in our data set. So our data set is basically different undergraduate majors and what salary do they earn and what group did we belong to. If I want to perform analysis on this data set, I need to find a major in which the salary in the 90th percentile of people and 10th percentile of people is minimum, so that average salary is high in this field. To do that, I need to calculate a low risk major, which is a difference between lowest and highest salaries. So to do that, you need to let's say we create a variable called spread, which is the difference between both, and it will be the difference between the highest salary, which is the mid career 90th percentile salary, minus the mid career 10th percentile salary. Mid career 10th percentile salary. So let's store this value in a spread variable named spread, and if I print this spread, you will be able to see that it is the difference between these two salaries. Now let's say I want to add this column inside of my data frame. To do that, we can use the df.insert function. Now what df.insert function uses, it takes in the location or index you want to uh, add this column to. If I pass in the index 1, it will add the column next to the undergraduate major column, which is 0 and 1. It will add it in between these two columns. So let's insert at location 1, and after inserting at location 1, we need to pass in the name which we want to name the column. Let's name it as spread and pass in the data, which is spread, which is stored in this way. And if I print df.head again, you will see that our new column spread has been added in our dataset, which is the difference between the 98th percentile salary and the 10th percentile salary. If we want to sort our dataset based on a specific column, we use something called as the sort values function in Pandas, which shows us which values have the, and it sorts the data frame based on a particular column and jumbles the rows based on that basically. To use this, let's try to sort our data frame and using the based on the spread column. To do that, the sort values function also returns an data set or a data frame. So you need to use the in place equal to true here as well. So let's try to capture it in a new data set. So let's name our new data set as new, and let's use the df.sort values on our data frame and pass in the name of the column which you want to sort the values on, and we want to sort the values on the spread. So if I pass in spread, the name here is case sensitive, so you need to be used to that. And if I print new dot head now, you will be able to see that the values are sorted based in ascending order. And if you want to see the value which has the highest value based on spread, you can also pass in an argument called ascending equal to false, which will sort it based in a descending order, and so that the highest value of spread comes first rather than the smallest value. So I will let it keep it in ascending order, and our sorted data frame is stored in the new variable now. So new becomes our new data frame. Now, if you see our data set, you can see that there is a column called as group, which consists of business, STEM, and has, and all the different undergraduate majors are part of one of these three groups. And let's say if you want to group the data based on these groups, how you can do that? So to do that, you need to use something called as the group by method in Pandas, which allows us to group our dataset based on a specific column values. So if I want to group by the group column, all I will do is I will call in my dataset, which is new now, and apply the group by function on it and pass in the column by which I want to group it. So let's say I want to group it using group column, and once I use the group by function, I can perform methods like count on it. So if I group by count, you will see that by grouping business, there are 12 undergraduate majors which are included in business group. Has 22 and STEM has 16, and the number of counts between them. If I want to count the mean of the values under the specific groups, I can just use this function, and instead of count, I can call in the mean function, which will return me the mean values present inside of this group. So you can see the group business had a spread mean of this much value and has this much values. Now, if you see these values, it's a bit confusing and it's a bit messy to read because there are a lot of decimals involved here. So we want to change the format in which our pandas gives output to us. So to do that, we can specify a number format in pandas. To do that, we need to use the pandas library, and under the options section in the display section, we use something called as float format, which allows us to format the output type of float variables. So these variables here are called as float variables because they have decimal type. To give the format, if you are familiar with C, you might know what I'm about to type now. So to format it, all you need to do is inside the curly braces, write a colon, comma, the format you want to follow. So I want to follow a two decimal format or only values in which two decimals are shown. So I'll write dot to f, which specifies that after the decimal, there should be only two integers followed. So this value will come out to be 103958.33. This will allow us to able to format our output better and simply write the format function. Now, if I write this function again, I will be able to analyze my output better. What's the error? Let me see. pd.options.display.float format equal to colon dot to f dot format. Yeah. So if I run this now again, you will be able to see that our outputs are much more readable now compared to what we were getting before. Now, if you are stuck till now, it's time for challenge now. So I have given you these three challenges inside the notebook. You can pause the video now, read what these challenges mean. I will explain it to you. So you need to find what college major has the highest start career salary and how much do graduates with this major earn. So you need to target the highest start career column, and you need to find which of them has the highest salary and how much they earn. Then the second challenge is to use the short values method and find degrees with highest potential. Highest potential means sort values on the 90th percentile group. So you need to apply the sort values on the 90th percentile column and find the top 5 of them. Then there is college major with highest career 90th percentile salary and what is the amount. So you can pause the video now based on what we have learned in this video and in this section. You can follow these same steps and try to solve this section now. Pause the video right now and I will unpause it in a few seconds and give you the solution to these challenges. Yeah. So let's start with the first challenge, which is finding college major which has highest start career salary. So let's work on our DF and we need to find which one has the highest start career salary. So to find that, you target the starting median salary, right? And you find in the IDX max, which returns as the value of maximum value under which this right. So it is under the 43 index. So I'll write df.log 43, which will return me the major which has the highest starting median salary. So you will see it's physician assistant, which has the highest starting median salary of 74,300. Yeah. So let's move on to the second challenge, which is using the sort values, find the degrees with highest potential. To do this, you will use df.sort values, and I need to sort values based on the mid-career 90th percentile salary. So I'll copy this column name. I'll store this in a new dataset, let's say clean, and I'll just print clean.head. And as you want the highest of these salaries, I will use the ascending equal to false argument so that it gives me the highest in a decreasing order. So you can see that based on these challenges, the degrees which offer the highest 90th percentile salary are economics, finance, chemical engineering, math, and physics based on the dataset. Now this dataset may be old, so some of these values might sound astounding to you, but we need to learn and we need to apply these techniques on any dataset we want to process. Now moving on to college major with highest mid-career 90th percentile salary. So to find this, we'll use DF and let's say mid-career 98 percentile salary and dot max. So if I write this, I'll get that the max 98 percentile salary is 21,000, which we can also verify here. And to find the college major, I will use the IDX max to find which lock I have to find to. It gives me 70. So I need to lock the 17th index in this dataset to find me the undergraduate major which has this salary. So it's economics, which we can verify from this challenge as well. So this is the end of the first section or the end of the first dataset which we have applied basic pandas methods and processing techniques. We will move on to applying advanced techniques as well on further datasets so that you learn advanced EDA as well. So these are some of the learning points and summary which you might be able to refer or when you want to revise these concepts. So thank you for sticking till here. Stay tuned for the next video and practice on different data sets of your choice these methods so that you are able to easily grasp such concepts more. Do like and share this video and subscribe to my channel. Message down below if you feel any difficulty or you have any doubts or if you're getting any errors. The link to this solution notebook will be also available in the description. So after this, we'll move with a different data set and apply different methods so that we can cover entire area of the EDA process and the data pre-processing step in our pipeline. Thank you for watching.